Hi, today we are going to see class 9 physics first chapter, that is motion, and the first subtopic under this chapter is describing motion. So let us define what is a motion. Motion is nothing but a movement. And when do we say there is a movement in an object? Yes, when an object moves from one position to a different position. Now, in our everyday life, we see many objects which are at rest and which are under motion. For example, the flying of the birds, or the swimming of the fish, or the rotation of the earth. So we say all these objects are under motion. Now, let us consider an example. Let us take an object and place at a point A. Now, is there a motion or movement of this pen? No. Why? Because this pen is still resting at a point A. Now, if we move the pen from point A to a new point B, then there is a motion of this object. Why? Because it is moving from a first position to a different position. So, now we can define what a motion is. So, technically, we can define motion as the phenomenon of change of position of an object with respect to time. Now, some objects may move in a straight line, and you can see some objects which takes a circular path. Some may vibrate and some may rotate. Okay, so in this chapter, first we are going to discuss about the motion of an object along a straight line. Now, let us learn about two different physical quantities which we use in motions. That is nothing but distance and displacement. Now, let us define what is distance and displacement based on an example. Let us take an object. Consider an object which moves from a point A to a point B, and again from point B it travels to point C. Okay, so point A is its initial position, and point C is its final position. And let us consider the distance between the initial position and final position to be 12 kilometers, and the distance from A to B is 10 kilometers, and the distance from B to C is 5 kilometers. From this, let us find out the value of distance and displacement. Now, by definition, what is a distance? A distance is the actual distance travelled by an object. What is the actual distance travelled by an object? Yes, the object has moved from its initial position to its final position. So, the initial position from A to B, it is 10 kilometers, and from B to C it is 5 kilometers. So together 15 kilometers. So we get the distance as 15 kilometers. Now, by definition, what is meant by displacement? Yes, displacement is the distance travelled by an object, or rather the shortest distance travel by an object from its initial position to its final position. So, this is its initial position and C is its final position. Now, in this example, which is the shortest distance between A and C? Yes, it is from point A to this point C. From initial position to the final position, and it is the shortest distance. So what is the value of displacement? It is 12 kilometers. Okay, so now let us compare or differentiate the difference between the distance and displacement. So by definition, as I have already told, distance is nothing but the total distance or actual distance covered by an object, whereas displacement is the shortest distance traveled by an object between initial and final position. Okay, now the SI unit, that is, we measure distance and displacement based on the SI unit. So the SI unit of distance is meters. Similarly, the displacement is also something related to distance, therefore it is having the same SI unit, and the SI unit of displacement is also meter. And the next point is distance is a scalar quantity. Whereas displacement is a vector quantity. And by the way, distance we represent generally using the letter D, whereas displacement we represent using the letter S. Now, let us see what is a scalar quantity and what is a vector quantity. Now, why is distance a scalar quantity whereas displacement a vector quantity? Let us consider an example to know why these are of different quantities. An object which is at point or position A travels to a point B and further travels to a point C. And let us consider the distance between the 2 points A and B is 10 meters, whereas the distance between B and C is 5 meters. Similarly, let us take another example. If object from point A, it moves to a point B and again it changes its direction and again moves to a different point C. And as I told you, the shortest distance is the displacement. So in this case, this is the displacement. And here let us consider this as 10 kilometers, this as 5 kilometers, and let us take this as 12 kilometers. So let us find out the distance and displacement for these examples. Distance, displacement. Now, what is the distance of an object which travels from A to C? That is the initial position to the final position. Yeah, by definition, it is the total or actual distance covered by an object. So, the value of distance will be 10 plus 5. So, we are going to get 15 meters. What about the displacement? As we have seen, the displacement is nothing but the shortest distance traveled by an object from its initial position to the final position. In this case, which is the shortest distance? Yes, it is the same distance from A to C. Therefore, the value of displacement would also be 15 meters. Now, let us consider the distance and the displacement for this example. The distance traveled by an object is from A to B is 10 kilometer. Sorry, here I have taken meters, so let us take meter there. Okay, I have changed the SI unit into meters. Now let us get into topic. Now, what is the distance traveled by an object from point A to point C? The distance traveled by an object from point A to point C is 10 plus 5, that is 50 meters. But in this case, what is the value of displacement? By definition, it is the shortest distance from initial to final position, and the shortest distance is this one, and the value of displacement will be 12 meters. Now, can you find any something which is different in these two pictures, in these two examples? Yes, there is a difference in the value of displacement. And why was the difference in the value of displacement? In these two examples, even though the direction of the motion of the objects are different, the distance are the same. The distance covered are the same. So, the distance does not depend upon the direction. It depends only upon the magnitude. So, distance depends only upon the magnitude. What is magnitude? Magnitude is nothing but a numerical value of the physical quantity. So now we are discussing about the physical quantity distance. So what is the numerical value of distance? What we have got? 50 meters. So this is nothing but the magnitude. Whereas if you see displacement, the displacement depends both on magnitude and direction. See here, the object is traveling in a straight line and we have got the displacement as 50 meters. Whereas in this example, the displacement what we have got is 12 meters. It's only because of the change in the direction of the motion of an object. Therefore, the value of displacement depends both on the magnitude and also the direction. Now, in previous classes, you would have learned what is a scalar and a vector quantity. What is a scalar quantity? Scalar quantities are quantities which depend only on magnitude. Okay, the quantities which depend only on magnitude are called as scalar quantity. So, if you see here, the distance depends only on magnitude. Therefore, the distance is a scalar quantity. Whereas, what is meant by a vector quantity? Vector quantity are the quantities which have both magnitude and direction. So here if you see, the displacement has both magnitude and direction. Therefore, displacement is a vector quantity. So let us look into the differences between distance and displacement once again. The distance is nothing but the total or the actual distance covered by an object, whereas displacement is the shortest distance of an object between its initial position and its final position. And the SI unit of displacement and distance both are meters. The distance is a scalar quantity, whereas displacement is a vector quantity. Now, let us consider three different cases. An object travels from point O, which is called as an origin or a reference point. It travels to a point A and it returns back and stops at a point B. Now, case 2. An object travels from a point O to a point A. Now, case 3. Let us consider an object travels from point O to a point A, and again it travels from point A to the point O. in this first example, let us consider the distance between O and A is 10 kilometers. And the distance between A to B is 5 kilometers. Okay. In case 1, what is the distance? The value of distance is 10 plus 5. So it is 15 kilometers. And what is the value of displacement? Since displacement is the shortest distance from the initial position to the final position, it is the distance between the point O till point B. So it will be 10 minus 5. Therefore, the value of displacement will be 5 kilometers. In this example, in case 2, we'll take the distance between O to A is 10 kilometers. So here, what is the value of distance? Yes, the value of distance is 10 kilometers. And what is the value of displacement? It is same. It is equal to the distance, because there is only one short distance, that is between initial position and final position. So you will get the value of displacement equal to 10 kilometers. Now, in case 3, the distance travelled by an object from O to A is 10 kilometers. And again the object travels back from A to O. So again the object has travelled another 10 kilometers. So in total, what is the distance travelled by an object? It is 10 plus 10, therefore it is 20 kilometers. What about the displacement here? The displacement is the distance between the initial and the final position. So here the initial and the final position both are at the same point. It is at same point O. So both are at the same position. Therefore, what is the value of displacement? It is 0. So if you want to see another example in case 3, you can consider an object which starts from point A, it travels and again it reaches at the same point A. So what will be the displacement? Here the initial point and the final point are both at the same point, that is at the point A. Therefore the displacement here will be 0. Now in case 1 the value of distance and displacement are different, because here the object is starting from O and it's somewhere in between. It is not ending at the initial point. So therefore you get a different value for distance and displacement. But case 2 the object is traveling from O and it reaches to a point A. So we are getting the magnitude, distance in displacement in magnitude are same. So when is the value same for distance and displacement? Only when an object moves in a straight line. But case 3 an object is starting from O and again it is traveling to a distance A and it is getting again back to its initial position. Therefore in this case, that is an object from initial position after traveling again if it comes back to its initial position, okay, in that case the value of displacement will be 0. So in this class we have learned what is meant by motion of an object along a straight line, and the two physical quantities which we learn in motion, that is the distance and displacement, and the difference between distance and displacement. So see you all in next class. Hope these concepts were clear, and if you have any questions you can just comment, and if you really like this class, please subscribe and share it with your friends. Thank you.